Hi and good morning, Salim. My name is MONESWARRAN and I like GUNASEGARAN from Section 7. Today, I, along with my group members, are going to present about our group assignment, which entitled as Unsupervised Technique in AI. So, what is K-means? K-means is a type of unsupervised clustering method. The main aim of this method is to group data with a K being the number of group depending on the type of given algorithm assign each data point to each one of K group so the data point are then segregated and grouped together based on based on their particular feature. As you can see, sir, this is an example of our result using K-means algorithm. Next, I'm going to show to sir about how to download UCR repository. So basically, UCR machine learning repository is actually a collection of dataset, domain concept, and data generator that the learning language understand to actually test machine learning algorithm empirically. So in order to download derivative 50 free dataset, we must search for the dataset in the internet. Then it will redirect us to a new website. After that, click download data folder. It will download as a zip file. Then we need to extract all the content into a normal file. After extract, we can choose either C50 test or C50 train. Then go to document. We need to create a new file name as data. So we are using a 6 class for our assignment 2. The 6 class we are using is Aaron Pressman, Alan Cusby, Alexander Smith, Benjamin Canlin, Bernard Hickey, and Brett Dorfman. After that, copy all the classes and paste into the newly created folder in rapid manner. I mean in document, which is data. That's all from me, sir. See you soon in class. Next, Sayush gonna present about the text processing operator, such as tokenize and transform case operator. Thank you.
Thank you, Monish, for your wonderful presentation. Hello, sir. A very good morning to you. My name is BALASUNDRAM. My metric number is AA200877. On this wonderful day, I would like to present about our process view for our assignment 2. As you can see, this is the process view. You are able to see 1, 2, 3, 4, 5 different operators that involve in the assignment 2 project. So now I would like to explain regarding the process document from files operator and also the operators within this big operator. First of all, as you can see, I've added 6 different directories as its parameter. As you can see, it starts from Aaron Pressman till Brad Toffman. Now let's enter into the design view of the process document from files operator. As you can see, there are 7 different types of operators within the process document from files. First and foremost, the extract content operator. This operator will provide the documents that are passed through as the parameter and extracts its content and information within it. Later on, it will be transmitted into the tokenized operator. This operator divides the string sequence from the documents into tokens. Later on, it will be sent towards these 2 operators, which are known as WordNet operators. One is find synonyms and another one is open WordNet dictionary. So the open WordNet dictionary contains a parameter that has a directory of the dictionary that has been downloaded. So the dictionary will be inserted as the parameter into the open WordNet dictionary. Later on, This will be used, the dictionary will be used for the find synonym word net that helps to find the synonyms of each tokens from the document. Later on, it will be transmitted to transform cases operator. In this operator, the parameter is set as lowercase. So the tokens will be converted into lowercase letters from the documents. Later on, it will be transmitted into the filter stopwords operator that has English language stopwords. It helps to remove all English tokens equal to a stopword from the given file. For an example, stopwords such as the, are the words that will be removed from the given file. Finally, the filtered tokens of the documents will be sent towards the stamp operator that uses Potter algorithm. It eliminates and removes grammatical ends of the English words from the document using the Potter stamping algorithm. For an example, listening and listen will be converted into the base or root word, which is listen. Finally, the appropriate result will be displayed after all of these operators successfully executed when we press the run button over here. So other operators such as clustering, map clustering on labels, apply model, and performance will be in detail explained by other group mates. That's all from me. Before I stop, I would like to say that in order to increase the accuracy of the performance result, we are able to disable this to WordNet in order to improve the accuracy of our result. Later on will be in the video as you will be explained truly by Farrah about the result. So that's all from me. Thank you, sir.
I am Farah. I will continue text processing from previous part, which is SARVEISH part. Before this, we already see what is processed documents and its operators such as extract content, tokenize, transform keys, stamp, filters, find synonym, and open word nets, and so on. Now, we will have another few processes that we can do because as we know, the more data we process, the more data will be accuracy. Okay. As you can see here, there is 1, 2, 3, 4 process of the process document, which is clustering, map clustering, and apply model, so performance. Okay, all of this we can get on the operator here, operator at the left side of the rapid miner. Just search by its name. For example, is clustering. Clustering, we take this one. Okay, means the first one, and then if you in to add the map clustering, so just go here under the segmentation, validation, performance, and segmentation. There is a map clustering on levels. This is for the apply model, just as we do before, just search its name, apply model. Okay, under scoring, there is apply model operator, and last but not least, the performance. Performance. Okay, the performance you can get on the validation, performance, and predictive. We will take the first one, which is the performance classification. That's it. This is the last operator that we do in this step processing. Okay, after we connected all of the operators, like clustering with the process documents, and map clustering with the clustering, apply model with the map clustering, performance with the apply model, and the end to the resources, then we can run to figure out the final result of the text preprocessing. It takes a quiet time because in the process document we already have another operator such as token, filter, and stamp. So, and we in this project we use 6 dataset, so it takes a quiet time. because many operators and dataset. Wait a moment. Okay, so here we go. Clustering. Okay, this is the final result of the all of these operator being performed. We can see it has been a dataset which this one Aaron, Alan, Alexander, Benjamin, Bernard, and Brad. This is all the 6 dataset, and the accuracy of the dataset is 53.67%. And at the right side of this result, we can see the class basis. So in the result summary, we can see the description of the performance and then annotation. Okay, so we go back to this workplace. Okay, now I will explain one by one operator, which is clustering, map clustering, apply model, and performance in this workspace. Okay, before we know each meaning, okay, all of these we call it as a k-means algorithm. What is k-means algorithm actually? Okay, k-means algorithm is determines a set of a k cluster and assign of example to S1 cluster. Okay, the cluster consists of similar examples. The similarity between examples is based on distance measure between them. Okay, that's for the all of this. What we call all of this is a k-means algorithm. And next we have before. The clustering is performed a random flag clustering of the given example set. Clustering is concerned with grouping objects together that are similar to each other but distinct to the object in the other cluster. Okay, after the clustering, we also have a map clustering. This operator convert cluster attribute into a prediction attribute. The map clustering on label operator takes input a cluster example set and cluster model. Okay, it is estimate a mapping between the specified clustering and prediction using this input. Okay, the next operator is a apply model. Okay, this is operator that usually a learning algorithm first train a model on an example set. Okay, this model may be then applied to another example set, and the purpose is to make a forecast based on previously unknown data or to alter data. And last but not least is the performance. Performance is used to return a list of performance iteration values. These performance standards are set automatically based on the kind of the learning task. Okay, that's all for me. Thank you for hearing my explanation.
Hi, I am SYAMILAH RADZI, matrix number AA200782. The output will be displayed as 2 separate viewpoints of 6 documents. Firstly, the performance vector. It is a list of performance criteria values. The performance vector is calculated on the basis of the label attitude and the prediction attribute of the input example set. The accuracy performance for without WordNet is higher than with WordNet, which is 70%, while with WordNet is 53.67%. Secondly, in terms of example set, which have 2 types, map clustering on labels and graph. This is the result table for map clustering with WordNet. There are columns for ID, labels, prediction, and confidence. The number indicates the result, which 0 is for no result, while 1 shows if there were a result. The next one is the result table for map clustering without WordNet. On this table shows the results. As you can see, figure 20 shows a graph with WordNet, and figure 21 shows graph without WordNet. The graph with WordNet is more crowded since WordNet is used to generate synonym words of each word piece from the sentence by using the WordNet dictionary.
Assalamualaikum warahmatullahi wabarakatuh. My name is NORDINI BINTI MOHD. My metric number is AA200094. So today I will be talking about the differences between supervised and unsupervised classification in artificial intelligence and machine learning, which is supervised and unsupervised classification. Image classification approaches such as supervised and unsupervised classification includes human-guided categorization, and software calculation. They are sometimes referred to as distance sensing technique. For example, forecast, grassland, farm, water, and urban classes. Supervised learning is a machine learning approach that defined by a use of labeled dataset. These datasets are designed to train or supervise algorithms into classifying data or predicting outcomes accurately. By using labeled inputs and outputs, the model can measure its accuracy and learn more over time. However, unsupervised learning uses machine learning's algorithm to analyze and cluster unlabeled dataset. These algorithms discover hidden patterns in data without the needs of humans' invention. Firstly, the difference between supervised and unsupervised classification is in terms of class. For supervised classification, it predefines classes based on information categorized. However, for unsupervised classification, it defines as the spectral properties. Besides that, the second differences between supervised and unsupervised classification is in terms of knowledge. So for supervised classification, it firstly applies the knowledge and then classify. However, for unsupervised classification, it firstly classifies and then applies the knowledge. Furthermore, the third differences is error. For supervised classification, it creates more opportunities for the operators to make error. However, for unsupervised, it creates less opportunity for the operator to make errors. Next, the difference between supervised and unsupervised classification is unique classes. For supervised classification, it allows unique classes to go unrecognized. However, for unsupervised, it allows unique classes to be recognized as distinct unit. In addition, the difference between supervised and unsupervised classification is information. For supervised classification, it defines useful information, categorized, and examines the spectral separability. For unsupervised classification, it determines spectral classes and defines their information utility. Last but not least, the difference between supervised and unsupervised classification is spectral data. For supervised classification, it imposes perception on the spectral data. However, for unsupervised classification, spectral data impose constraints on interpretation.